Hello and welcome! Today on Minecraft we're going to move blocks around. We're going to create an item that will take ore blocks from below us and they will slowly surface to the ground level. And also we will do this in a way that will be testable. Are you ready? If so, then let's go! When searching for the ore block to pull up, we will use the fact that in Minecraft all blocks are in fact singletons, and we can perform a simple equality check on the block from the block state against the block from the block registry. So for this, let's create a new adapter for a block and change our block registry so that we can get the block. Also, we will override the equals and hashcode methods so that we can perform a simple comparison on our adapters. Now let's create the class for our item. We'll call it Ore Attractor. Now let's create our behavior class. Now let's start with our logic for the search algorithm. First, let's define a set of ores that we are interested in, as well as let's get a reference to bedrock so that we will know when to stop. And for our search algorithm, we will make a simple breadth first search, which for the given level will search all of the adjacent blocks to see if there are no blocks of the type that we are interested in. It will do so until we reach our desired search radius, after which, if the block was not found, it will descend one step lower and do this again. And this will continue until we either find a block of interest, in which case we will return it, or we will reach bedrock, in which case we will return null, because that means we have dug very deep and there is no place left to dig for the block. Let's start by defining a helper function that will tell us if the given block is an OR block. And for this we need to change our block state adapter. We need to add one more method here. And now for our search method. First, we will check if we reached bedrock. And now we will create a helper function to perform the breadth first search. We'll start by defining two collections. One will be the list of positions to search, and the second one will be a set of positions that we have already searched. And now we will take our positions from this collection until we have exhausted all possibilities for this level, in which case we will descend lower. Next we will compute the current radius for this position from the center. If we haven't found this OR yet, then we will now add all the neighbors to the search list. And after we exhaust every position for search, we will just return null. And now, from our search download method, we will just return either the breadth search, or if it's null, we will continue to search downward in a recursive fashion. And in the end, it will give us either null if we haven't found anything, or the block and the position of the OR. Now with this, let's use this to move blocks around. And if we found anything, we will just swap it with the block that it's directly above. And now we can proceed to testing this code, but since we have changed some adapters, then first let's check if we need to make some changes and adjustments to our previous tests. And as we can see, we need to adjust our adapters, our doubles. So let's do this right now. Let's start with a block double. And we will make it a data class so that we can conveniently compare its instances. Also, let's do some more changes and remove this error. And instead, we will just check if the ID matches the identifier for the ID. Also, for the block registry double, we will also change our world adapter a bit so that we will store our blocks in the map now. And we also add a depth to the world. And now we have to slightly adjust our tests. And now that everything passes, let's create the test for our Ore Attractor. Our first test will check if the Ore will be pulled up. And for this assertion, we will extract only the values that we are interested in, just in case we would like to extend this double in the future. And our first test passes. So now let's check if our radius limitation works. And the block should not be moved. What we can also do is right now we are testing only if the coal ore block is moved. So we can change this test into a parameterized test that will check all of the ores that we are interested in. So let's do this right now. And we will use a CSV source to supply parameters. And what it will do, it will take all of these values and substitute them in as this parameter. So now we can see that it has run 4 tests, each for a different ore block. Now let's add our new item to the game. And let's run the code to check if it works. So let's find some flat terrain. And here it is, our coal ore. And there's just one more thing that we have to take care of. And that is, if we put an ore and directly above it we will put a, for example, chest. Then after we use our item, the chest will drop its item. So let's fix this. To fix this, we need to, instead of just moving the blocks, we need to also move block entity that is associated with this block. And for this, we need to create 2 more adapters. One will be for block entity, and the second one will be for NBT compound. Let's start with the NBT compound. And in case you're wondering, the NBT compound is the way that Minecraft stores the data for the blocks. And the reason we also need this NBT compound adapter is that a creation of block entity from NBT is done by a static method on the block entity class. So now that we have it, we can return to our Ore Attractor and write the missing logic. So first, if there is a block entity associated with this block, then we should get it and extract an NBT compound. But before we do this, we need to also change our world adapter with functions to get a block state entity. So now back to our attractor. Let's check if we have an entity. If so, then let's create an NBT. And once we remove the entity from the target position, let's place it again. And now for our tests, we also need to update our doubles. And now for our test. And the reason why we are including ID here is that this ID is defaults to the random UID. So if our code does not work, if this NBT compound will not be used to create a new block entity double, there will be an error on the entity ID. All tests pass, so let's check this in game. So let's put something inside this chest. And let's place an OR block directly above it and directly below it. And now let's check. And the chest retains its items. So as we can see, our code works. Right now, we know how to create blocks and we know how to move blocks. And with each episode, our framework grows and grows, and we're able to more accurately mimic the behavior of Minecraft without using too many Minecraft specific classes and avoiding tightly coupling with Minecraft. However, our code has one little bug. As you could see in the demonstration, the OR blocks that surfaces, it stops moving after it reaches our eye level, which is too high because it ends up floating in the air. And this is something that could be fixed, that could be tested. And if you would like to get your hands dirty, which I strongly encourage, then download the code from GitHub and try to create a relevant test and fix the bug. From my side, I will also create a test. I will fix this, and the code with the fix will be updated. It will be pushed before the next video with a different tag. Something like part 3 exercise. And this concludes this video. Thank you very much for watching, and I hope to see you again on my channel. Thank you, goodbye, and have a nice day.